Hello everyone. We have established that sound travels in form of a wave, in particular a longitudinal and mechanical wave. The sound wave resembles these waves based on its behavior, but sound wave itself also has its features. Let's study the characteristics of a sound wave. This diagram shows us that sound travels through a medium by changing the pressure or density of the particles of the medium. C refers to the compressions and R refers to the rarefactions. These two are the way a sound is propagated through a wave. Compressions are regions where density as well as pressure are high. Where you can see that the lines or dots are too close to each other, it is a region of compression. These particles are exerting high pressure on themselves as well as the adjacent particles to propagate the sound. Rarefactions are regions where density as well as pressure are low. You can see that in some regions the light and dots are far apart. These are the rarefactions. The density as well as pressure in these regions is much lower than those in compressions. We call sound a wave. This diagram certainly does not look like a wave. So next up, we are going to study the real wave of sound. We will start off by marking where compressions and rarefactions are in the wave. This is a regular sound wave. As you can see, this variation is of density and pressure of the particles of the medium. The line which interjects the wave is the average density or pressure. Lastly, as the wave moves to the right, distance is increasing. Compressions and rarefactions and several other characteristics of the wave are shown by this sound wave. Compressions are represented by the upper portion, while rarefactions are represented by the lower portion of the wave. The line for average is what divides the wave into an upper and lower portion. The region where compressions are represented is called the crest. Since the density and pressure is high, this is a compression. On the waveform, crest is the term used to describe it. On the other hand, where the pressure and density is low, this region is of rarefaction and is called the trough. So, a peak is called a crest and a valley is called the trough of the wave. Here we have the label sound wave again. As we learn the new terminologies, we will keep adding it to the diagram to understand the full picture. The distance between two consecutive compressions or two consecutive rarefactions is called the wavelength. This region marked by the arrow is called the wavelength and is represented by this symbol. The symbol for wavelength is lambda and the SI unit is meter. Lambda is a Greek alphabet and is used in place of wavelength. SI unit is the internationally accepted unit for a quantity. It is important to remember the SI units. So, wavelength lambda is written in meters. The magnitude of the maximum disturbance in the medium on either sides of the mean value is called the amplitude of the wave. It is represented with the alphabet A. The mean value of the wave represents the line which separates the wave into two equal halves. It refers to the mean value of the density or the pressure. So the amplitude is calculated from this line to the peak. So this is the amplitude of the wave. This is a rather finished diagram of the wave with its basic characteristics, but there are some more which have to be looked at. So for this, we will take an unlabeled wave diagram to understand. The change in density from the maximum value to the minimum value, then again to the maximum value makes one complete oscillation. You may have learned that a pendulum oscillates. An oscillation is basically an object coming back to a certain point after crossing all the points in a system. Here, the maximum value refers to the crest and the minimum value is the trough. So one oscillation is made up of the wave passing through one crest, one trough, and back to the crest. This dotted line represents where the oscillation is of the wave. The number of such oscillations per unit time is the frequency of the sound wave. It is denoted by the Greek letter nu and looks like a slanted V. Frequency is a count of how many times a thing happens within a certain time frame. So if you could write 5 words in 20 seconds, someone else can write 7. So their frequency is higher. Since we are already talking about time, let's look at the other characteristic of a wave. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called the time period of a wave. This is a rather complex definition. This arrow marks the time period of this wave. A simpler definition can be derived from this. The time taken for one complete oscillation is called the time period. Now, time period is for one oscillation, but number of oscillations in a certain time is called frequency. This may sound confusing, but if we derive an important relationship from this, we can understand sound better. For example, if one oscillation is completed in 20 seconds, the time period is 20. However, if in 60 seconds 3 oscillation takes place, frequency is 3. This relationship is simply seen as frequency is equal to 1 by time period. This is an important formula and one of the most simplest one in this chapter. Moving on to simpler things, what is the difference between the voice of a man and a woman? They sound very different. Why? Because of the pitch. How the brain interprets the frequency of an emitted sound is called its pitch. Let's see this with a wave. The T here represents a certain time since pitch is related to frequency. Here we can see that the wave has completed about 1.5 oscillations. This is a low pitch sound, like that of a man. On the other hand, this wave shows much more oscillations but in the same time period. This is a high pitched sound. What can you understand from these two? A relationship can be drawn from this. Frequency is directly proportional to the pitch. The source of the object vibrates at a higher frequency to generate a sound that is higher in pitch. So higher the frequency, higher the pitch. Lower the frequency, lower the pitch. Have you noticed that some people are louder than others? Let's see how. The loudness or softness of a sound is determined by its amplitude. The amplitude of the sound wave depends on the force with which an object is made to vibrate. Recall that the amplitude is the distance between the mean value and the peak of the wave. A higher amplitude is generated when an object experiences higher force. If you tap gently on a table, the sound is soft. As opposed to this, if you hit a table hard, a loud sound is produced. In terms of waves, a shorter amplitude corresponds to a softer sound, whereas a longer amplitude gives a louder sound. Now, it's possible that two objects have the same pitch and the same loudness. Then, how can we differentiate between the two? The quality or timbre of the sound is the characteristic which enables us to distinguish between sounds. So, if you and your friend say at the same speech and loudness, your teacher will be able to tell you apart because of the timbre of your voice. A sound of a single frequency is called a tone. Every sound has a frequency, but if the frequency is not changed, the sound has a tone. Speed of sound is defined as the distance at which a point on the wave, such as a compression or rarefaction, travels per unit time. If you pinpoint a compression on a wave and track how far it goes in a minute, you will be able to calculate its speed. The formula for speed is known. Speed is equal to distance by time. Since the distance in a wave is given by the wavelength, we can substitute distance by wavelength and time by time period. So speed is equal to lambda by t. Remember when we had obtained a relationship between the frequency and time period? Time period is the reciprocal of frequency. So t is equal to 1 by f. We can substitute this in the formula for speed. We get speed is equal to lambda into frequency. In terms of words, this is speed is equal to wavelength into frequency. This is used for a speed of a sound wave. These are all the characteristics of a sound wave. By keeping the diagram of the wave in mind, it will be easier to remember all the parts and definitions. Remembering the derivation of formula is also important to fully understanding how a sound wave behaves. Thank you, and I hope you've gained something from it.